it says you're going to add the first child to the second child to the third child. And when you do that, you're going to get 20. Okay. We don't know the amounts of these children yet. That's why we have to express them with X, because that's the unknown. That's the part we don't know. But what we do know is that whatever the unknown is, he's going to make twice as much as that. He's going to make $1 less than that. You see what I'm saying? All I did was just translate those words into these X's and numbers so that I can solve it, because you have to change them into numbers to solve it. So now, instead of saying child 1, 2, and 3 are going to add up to $20, now I have a way to express child 1, 2, and 3. It came out to this. Now I can add together, I can do what it says to do. It says to add these, well, I can add X's to X's. I can add 2X plus an X and get 3 X's. Add another X to it and get 4 X's.
For some reason I was thinking you couldn't add them.
You can add X's together. I can't add X's with numbers.
That's right. Okay.
Because if I tell you if that X is a balloon, then I can say if you get 2 of them and get another one, you know you have 3 balloons. But now if X is a balloon, yeah, 1 is not a balloon. 1 is just a number. So I can't add 2 balloons into 1 and say I got 3 balloons. You see what I'm saying?
X's go next to the number.
The X's are with whatever they are. This says I have 2 of them.
Yeah.
It says I have 2 of those things, whatever they are.
So you add the other 2 X's over there with it.
I can add this X to it because it's the same thing as these are. I got
So
2 of them, I got another one.
What if it wasn't no 2 right there and it was just X plus X plus X?
I'd have 3 X's, yeah.
Okay, that's where I was getting, I don't know why I was getting confused right there, but for some
So you have to
reason
think, that's why I said two of them is what I would call them. You got 2 of them, whatever they are. You're getting another 1 of them and another 1 of them. Whatever they are, you now have 4 of them. We don't know what they are yet, but we know we have 4 of them. And from that, we got to take 1.
Okay.
This 1 is not one of them, so I can't say that I got 3 of them left, because we don't know what this is. We don't know what these are yet, you see? That's why the numbers got to stay with the numbers. Now, if I had 1, and then I had a +2 and a -5, I could do all those numbers together because they're all numbers. I know what they are. And I can do all those X's together. But I can't mix those 2 together and call them one thing.
Right.
So now I said 4 of them, whatever they are, when I take 1 away, I end up with the number 20. The only way to take 1 away from something and end up with 20 is if this was 21. You see what I mean? That's no mystery. That's a mathematical fact. This all together, whatever these things are, when I multiplied it by 4, I had to come up with 21. That's what I know. Because this says, when I take 1 from it, I'm going to get 20. Okay? So I had to find out, what can I multiply by 4 and get 21, so that I can take 1 from it and end up with 20. So to find out what that is, I divided 21 by 4. And I found out that $5.25. If I have 4 $5.25, I'd have $21 and take 1 from it and have $20 left. So now I know that X has to be $5.25. And who's X? That middle child. Because I already told you in the first place the middle child was X. So I know now that middle child is going to get $5.25. I said the oldest child is going to get twice as much. He's going to get $10.50. I said the youngest child is going to get $1 less than the middle one. How much is he going to get? $4.25. And when you add all that together, there's your $20. You see what I mean?
Why don't they just say what they want?
They did say it. But if you had $20 and you had to figure it out and say, this little kid, I didn't want my little baby brother getting as much money as I'm getting because he ain't doing nothing. So if you don't know how to do it, you say, well, I got $20 and y'all each getting $6.33 and a third because I don't know any other way to figure it. Or $66, 66 cents, I mean, and 2/3 cents. You see, this is a way you can do it, figure things out when they're not always even. Everybody doesn't always do their share in something. Somebody does twice as much they are gonna get paid twice as much. But you don't have an infinite amount of money. You have a finite amount of money. You got $50. $50. You gotta figure out how can I divide that $50 three ways where one's getting twice as much as the other one and one's getting $1 less. You'll be sitting there all day trying to figure out what that number is. When you can figure it out just like this, as long as everybody's pay is contingent on the same thing, you see. One's double this, one's $1 less than this. They can't be all together different, because if they're all together different, you can't figure it out definitively for all those different numbers. You can say, well, if this one makes that, then in order to be double, he's got to make this, he's got to make that. If this one makes this. But the only way you can figure out what it has to be, the one thing that it has to be, what X is if everything is based off of the same thing. And that's how all these problems will always be. You'll always have to find out, okay, who's the X? And the X is always the one that they don't say anything about. It's the one that somebody's making twice as much than. Because that's the 2X, so then he's got to be the X, you see. Let's look at the next one. I love this next one. Paul, Jeff, and Jerry work together repairing Paul's car. Okay, so I would someplace already, I would have P, J, and JR. See what I mean? Because you know they're getting ready to start telling you something about them, and you're going to have to start labeling who they are. Okay, you got those initials? Jeff worked twice as many hours as Jerry. So who's the X? Jerry's the X, so I put an X next to JR. Jeff worked twice as many, so Jeff worked what?
2X.
2X, okay? And Paul worked 6 hours more than Jeff. So what's Paul?
What'd you say?
Times 6.
You got the book, you read it.
Ah.
It says Paul worked 6 hours more than Jeff. How are you going to write that?
6 plus 2x.
No, 2x plus 6.
2x plus 6. Always put the x's first, you're right, but the x's always go first.
2x plus
Because it's Jeff plus 6, right?
Yeah.
Who's Jeff?
Okay.
Jeff is, see, as soon as they say Jeff now, every time they say Jeff now, you have to say
Right.
2x. is
Okay,
Jeff.
I'm following you
So
now.
it's Jeff plus 6, you see what I'm
Yeah.
saying?
Mm-hmm.
They spell it right out for you.
Mm-hmm.
And it says all together, that means they did what to them?
Equal, sum them up.
Add them all up.
Yeah.
All together, they equal 51 hours of work.
Okay.
So now you got 2x plus x plus 2x plus 6 equals 51, right?
Yeah.
That should be all in a line left to right. You see, right? So now how many x's do you have?
3.
5.
I got 3 different answers here.
5x.
5x.
Yeah.
Okay, 5x plus
start
6.
Plus 6. Write that at the bottom, up under there, Miss Harris.
Wherever you want. I just always keep taking it down. I write it, then when I solve something, I make it a new problem, a new equation. I keep moving it down. So now you have, what do you have? 5x plus
Plus
6
6.
equals what?
51.
So now you know right here. Something plus 6 equals 51. What plus 6 would give you 51?
44.
45, right? And I know that 5 times something has got to give me 45.
9.
9 has got to be what x is, right?
Yep.
But the question is, how many hours did Paul work? What is Paul?
2x plus 6.
2x plus 6. So how many did Paul work if 9 is x?
24.
You see how you can go on?
Me too. I lost already.
Going.
You said
Okay,
the X
well,
is
we'll go from
9,
there.
but you said the X is
I'm
9.
asking you, is it 9? What do you have that, what do you have, how far have you got?
5x plus 6.
Equals 50, well, you don't have what it equals.
51.
Okay,
I got
So what you
45
have-
plus 6.
huh?
45 plus 6.
Okay, wait before, let's go back there. What you have is 5 times some number
Plus 6.
plus 6 gives you 51, right?
Right.
So you ask yourself, what plus 6 would give you 51? And you found out that that had to have been 49.
Yeah,
45.
I mean 45, 45.
45.
And so 45, that means that 5 times some number, because it says 5x is 45, right?
Mhm.
So we know that 5 times some number, that had to equal 45. What does that number have to be?
5 times
9. So that x had to be 9, right?
Right, okay.
In order to multiply it by 5 to get 45. You go on and do it your way at that point, Deborah. You said when you get here, you had 5x equals 51? No, 5x plus 6, right? Equals 51. Then what you should have done then, the way you did it was like this before, right? You still get your 9. You can do it your way. What we said right here is that 5x plus 6 equals 51. I knew that all of this together had to equal 49.
Right.
45.
Why do I keep saying 49?
45.
45.
Plus 6.
I knew that this had to equal 45. That meant that this quantity, 5 times some number, had to equal 45.
Equals.
So this number here had to be 9. Because 9 is the thing times 5 that would give me this 45 that I needed. But that's the x. The question wasn't, and we said that x was somebody, who?
X is
Jerry.
Jerry.
And who else? Jeff is who?
2x.
2x. And Paul was
2x plus 6.
2x plus 6. And they asked me, how much did Paul work? He worked 2x plus 6, 2 times whatever x is, plus 6 more. We said x was what? 9, right? So Paul is 2 times 9, 18, plus 6. He worked 24